right, guys, so we're starting with looking at some graphs with inverses, but this is absolutely not a graphing unit or skill or whatever you want to call it, okay? These graphs will give you the why of what we do in a little bit, but at no point am I going to be like, okay, graph the inverse sine function with a phase shift and a period change. No. That is not a thing. We're just graphing it to understand why we do what we do with inverses. So we need to graph our parent graph for sine first. Can we do that? I hope. It took a turn.
Oh God, I didn't know what you were talking about.
My labels are small, but I think you guys know them at this point, right? Hopefully.
We know what the oh, but you're saying yeah, for free.
That's just sine. Okay. All right, guys, so for graphing the inverse, what do you know about inverses just in general? Not trig inverses, but switch x and y, yes. So my little grid over here, this is where we're going to graph inverse sine. The labels I originally did for the x-axis are now going to be on the y-axis. And y-axis labels will be on the x-axis. So inverse sine of x. So 2 pi, 3 pi over 2. Does this just feel wrong? Struggling here.
You're so judgy. I'm just asking.
We got this.
No, I started it looks fancy. Like it was fancy on your
All right, guys, so to plot the points, let's actually look at some points on our original sine graph. And then we're going to switch the x and y, plot them on our inverse sine graph. So we'll start at 0, 0. That's nice. Because when I switch them, what do I still have? All right, so that's my first point over here. The next point, hey guys, up here, is pi over 2, 1. So what am I going to graph on mine? 1 pi over 2. Then I've got pi 0. So what will I graph?
0 pi.
Okay. 3 pi over 2, negative 1. Are we seeing it? Okay. You can think through all those points on the left side of your original sine graph, or you can start just following the pattern on your inverse graph here, whatever works for you. I'm going to keep plotting these. And then you connect them. You like that graph better?
It looks like
It does.
It looks cool. It looks 3D.
Yeah, I agree.
Yeah. That's the new sign.
That's the new sign. We like this one. Okay. Everybody all right with the actual graph? Is that a function? No. Okay. Yeah, that's not going to pass the vertical line test. So what we have to do is we have to zoom in on a specific window here that, number one, is a function, and number two, actually covers all of the values from -1 to 1. Anybody have a guess as to what section we might want to use? It's the reciprocal, not those two words everybody likes to mix up. So it's okay. Yes, I like this window right here, guys. We did negative. Negative pi over 2 to pi over 2. Do you guys agree that that would pass the vertical line test? Like if that's the only part we look at, it's now a function, right? And does it cover everything from -1 to 1?
Yes.
Okay. So that is the window we have to use. So down here I'm going to just write negative pi over 2 to pi over 2. When we get to evaluating inverse functions, which we're doing today, but this will make more sense as to why we have to narrow it on that specific window. Okay? There are other windows that would obviously still be a function and cover everything, because this graph, you know, goes to infinity. But that's like the accepted window that you can answer from, okay? So that's one we're going to use. Questions before we graph cosine? We're not going to graph all 6. We're only going to graph 3 of them. Okay, so let's try cosine. So again, graph the parent function first. Then graph the inverse. I'll let you guys try this one on your own. All right, guys, let's look at your graphs.
You can just turn your paper. Oh, here, keep your paper. I hated math like officially beat the game. Like, yes, yeah, that's a good time. This is a good day.
All right, guys, there's your inverse cosine graph. How do we do? Troubles anywhere? Okay. Yay. All right. Again, not a function, right? So we need to pick a window. Should we pick the same window? No, that would not work. I would go 0 to pi. Yeah, do you guys see it? That little section. Again, there are other windows that would cover those same values, but this is the window of choice, okay? Do you see it? All right, let's do tangent. Last one we're graphing, okay? Hush. What's the period of tangent, guys? Hi.
I just made a dance.
Once you get pretty interested
So guys, what's going to happen on your inverse this time? It's going to be sideways. What kind of asymptotes are we going to have? Okay. Wow.
One of the notes we made on my sheet what the speakers
How's your graph looking? Got it? Okay. It's working. Takes a while. It's very tedious. I know, mine are always so small up here. I'm like, you guys know those numbers, right? You clearly cannot read any of those.
Yeah, I missed like.
Oh no.
Who actually did this the wrong way? First it's going like so yeah, why don't you also
Just think about the point pi over 4, 1, like over here, right?
I mean, look at the direction you're
So it's going to be 1 pi over 4.
because you got little to go.
I know a lot of you want to just like turn your paper and have it look that way, but that's not how inverses work. It's not a rotation 90 degrees. It's a reflection across the line y equals x.
But that's math.
Yeah. It's in November.
It's been a while.
All right, guys, what's our window going to be on this one? Yep. Now, they are asymptotes, but we're going to go ahead and just call it a closed interval because we want to include those values. We want undefined to be an option for an answer for us. So it does, yeah. But it's an asymptote, so it's not actually there. You do get undefined twice, but it's not a y value. It's matched with your x value. You'll understand it when we start evaluating. All right, anybody need more time on the graphs? Again, not a graphing unit, okay? Not a, yeah.
Oh, is this like a
For many different skills. No, there was one free response with every skill. Yeah. The very last skill we'll see, because remember, I guess your conics last time was all multiple choice, but conics was kind of the same thing. We'll look at the last one, because you kind of only get 2 times on that one. So. All right, we good? Okay, we're going to draw a couple circles. Not scary at all. Make you guys like look away. Roll.
Maybe it'll be a rectangle.
It's not a graphing unit, guys. It's not graphing. All I'm asking is draw a circle. I do have an advantage on the circle drawing.
Oh no, not good, guys.
You're gonna label like just tick mark labels.
Oh,
I cheat. I use this thing. I find though when drawing a circle by hand, like don't try to go slow. You'll mess it up. Like just draw the circle. Commit to it. All right, guys. This first circle. All right, inverse sine of x. What was the interval we picked for inverse sine? Okay, so do you agree negative pi over 2 is down here? And then I'm going to color all the way up here to positive pi over 2. Okay? So the right side of the circle is the side of the circle I want for my inverse sine. And I'm going to label things. This we know is pi over 6, pi over 4, pi over 3. Guys, if you know your unit circle, today's pretty easy. If you don't know those values yet, please learn them because it's going to get harder. All right, now fourth quadrant here. Normally we call that first tick mark 11 pi over 6, but we're not going to do that. What are we going to call it this time? Yes, good. I've got the negatives. So if I ask you an inverse sine question for evaluating, those are your answer choices, and that's it. Okay. There's not that many. I know someone second period was like, oh, I can just like draw them out of a hat, and I've got a chance. I was like, well, yeah. Yeah, it could be 0. All right, let's think about inverse cosine then. What was my window for inverse cosine? 0 to pi. So here's 0. Come around pi. Okay. Am I going to have any negative angles on this one? No. Just normal. Pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6. So no matter what I'm asking you, if you give me a third quadrant answer, I'm going to say, what are you doing? That's just not a choice for any of them. Don't ever go to the third quadrant.
What's the wrong?
Okay. We need to figure out where the remaining 4 trig functions go. Are they in the blue circle or the red circle? So inverse tangent, we know. Where does it go? The blue, yes. What?
Oh, yeah, because it's negative pi over 2.
Right, we graphed it. The window we picked, wasn't that negative pi over 2, pi over 2? Okay. What do you think is also going to go with sine and tangent over here? Cosecant, yes. Okay. So over with inverse cosine, the red part of the circle, what are we going to put here? Yes, to both of those. Inverse cotangent, inverse secant. And cotangent and tangent, they don't match up because if you think about their asymptotes, totally different asymptotes, right? Okay, so they're separate. Yes.
I feel like I have that question, but if cosecant is sine, why is the inverse of sine not?
It's not the inverse sine, it's the reciprocal. Yeah. All right. We got our circle parts here. We're okay? Okay. Let me show you what you actually have to do with this now. You will be evaluating. Let's say I give you inverse sine. Negative root 3 over 2.
What is going on?
There's no logs today, guys.
Why are you talking about
No logs in skills 7. You're... Nope. Okay, guys. Let's think about this. So the process you need to go through. It's inverse sine, so am I using the blue or the red circle? Blue. You need to think about which of these spots does the sine equal negative root 3 over 2? Okay, it's negative, so is that in the first quadrant or the fourth quadrant? Okay, so we've narrowed it down to these. Where is the y value? Negative root 3. Do you guys see what I mean? That if you don't know those unit circle values, this is kind of gonna not be real fun. But if you do,
Oh, where is it? Yes. Negative power of 3 would be 1/2 comma negative.
yes. Yep.
I do understand.
All right, inverse cosine, root 2 over 2. Pi over 4 is the answer. Right faster. Inverse sine of root 2 over 2 and inverse cosine of root 2 over 2 are the same thing. That's the only one. Well, inverse tangent, inverse cotangent, that one also. Secant, cosecant. But only pi over 4 is the only spot it happens. Okay. What, Henry?
Also 0.
All right, another way to write inverse. This means the exact same thing. If you see arc,
Oh, no.
it means the same thing.
Arc tangent?
That's the same as if I had written inversing. Okay, same thing. You are going to see both of them on your homework, so I want you to not get to your homework and go, what is this? What is showing? It means inverse. I don't know. I would say yes. Henry, you're going to see it written with arc sometimes. I want you to know what it means. Because they want to, Henry. Because they want to. Okay. Which part of the circle are we using? Blue or red? Blue. It was negative, so you know it's in the fourth quadrant. Think about your shortcuts. Where does tangent equal the root 3?
Guys, it's one of them. It's one of them.
Because what is 3 plus 3? That's how I remember that one goes with the over 6s.
And then 3 plus 0 is...
3 goes with the 3. 6 goes with the 6.
Oh, we're throwing. We're throwing.
So, what is our answer for this one?
6.
Negative pi over 3.
Get out of here, right?
Yeah.
No, it's not done.
Oh, yeah. Share with us, Neha.
Inverse three functions are where is either value of a three function may produce the length of the arc equal to the value. So it's just because
We all feel very
it's like
fulfilled.
when you are given the value of a trig function, the inverse functions produce the length of the arc equal to achieve that value. So it's just because you're going the other way around in the arc. So it is
That help anyone. All right, guys, try number 4 for me.
Cosine of all.
It's like what we did in the first one.
Wait, but the normal
So why didn't you have inverse of sine? Regular cosine.
All right, guys, you start on the inside, work your way out. You're like, baby.
What value has a sine of 1 half?
cosine of that is
Oh,
That's what I think through, but yeah.
5/6.
Okay, guys. Start on the inside, work your way out. Inverse sine of 1/2. Where does that happen? Pi over 6. And what is the cosine of pi over 6?
Square root of 3 over 6.
There we go. Yes. Questions on that one?
Literal boss.
He was a 40.
A thorny one? We'll get to one. There really aren't that many thorny ones in this.
Oh, yeah.
Let's go this way. All right.
We got baited. I'm gonna keep doing this all day.
Wait, that.
So guys, when you have an inverse of itself, do you think they just like undo each other and the answer is 7 pi over 6? It's a good theory if the angle is in the first or second quadrant for cosine, or like the negative pi over 2. 7 pi over 6 is in the third quadrant. Okay, guys, is your answer going to be an angle or a side length, like a coordinate point? Angle. Good. I heard angle in the back. Yeah. When you're solving for an inverse, your answer should always be an angle. Guys, like pi over 6 is an angle. Okay. Maybe we need to clarify that first. If you do inverse of something and tell me like root 3 over 2, that doesn't really make any sense. Okay, can't do that. You should get an angle as your answer. It could be in degrees. It mostly will be in radians. So this, you should end up with some sort of radian answer at the end. If I start on the inside, what is cosine of 7 pi over 6? Okay, so then it's not going to be 7 pi over 6 as your answer because that's third quadrant. You do not like the third quadrant. Yes, 5 pi over 6.
Oh, it is also the whole. So you didn't actually choose the unforbidden angle.
Choose the unforbidden angle. Choose the angle that's in the part of the circle that you can use. Yes, the unforbidden angle. So what's happening here like here's 7 pi over 6, right? So we can only use this part. So you need to figure out, like, okay, cosine's negative here. Where else is cosine negative? It's in the 5 pi over 6. Okay. Yeah, okay. Well, it has the same cosine value there. But that's within the window we can use. Right? If you tried to tell me 7 pi over 6, I can only use answers in here. 7 pi over 6 is outside of that box. So that can't be the answer. So you have to figure out what actually has the same cosine value that's within this window. It needs to be a function, and it had to cover everything from -1 to 1. So that's why we picked that one.
The inverse, you could have done this negative. Oh wait, no, I transformed to the other thing. You could have done it.
What are you saying right now, Lana? You'd have negative pi over 6 as your answer. Yeah. Yep. All right, guys, I need to walk you through this one. All right, guys, it's -3/5 something from your unit circle. No. Okay, so let me show you what you have to do on this one. Inverse cosine, your only choices are first or second quadrant, correct? Okay. This is negative, so we're talking second quadrant. You have to draw a triangle for this. All right, which side is the -3? Yeah. 5 is the hypotenuse. What's the other side of my triangle? 4. Okay. Remember, the whole purpose of arc cosine is to get an angle as an answer so that you can then take sine of that angle. The angle is just the theta in your triangle. So I'm now asking you, what is sine of theta? There you go.
Wait.
Okay. Yes. Yes. Because that's the angle. Same as inverse. Yep. Yeah. Okay, you guys try one. All right, give that one a try. It is -5 over 13. What? Do you know your Pythagorean triples? All right, guys, what quadrant is my theta in? No.
So if you take any odd number squared, it'll always be an odd number, right? So if you always take an odd number and divide by
Are we okay with the triangle drawing? Now I'm just finding tangent of that angle, and I get negative 5 times.
That squared is 49. And any odd number is an odd number is an odd number.
All right, guys, one more.
Squares are plus 576 or 625 yeah. Okay.
I'll walk you through it, guys. Just try to count first. So we're solving from 0 to 2 pi. That means all the way around the circle now. Do you notice that nowhere in this problem is there an inverse or an arc or anything like that? Okay, that means we are not thinking about the restricted circle or restricted windows or anything. You're just telling me where will this be true, and it's asking you all the way around the circle. Okay, so basic solving here. I would subtract the 1. I would divide by 2. So, where does sine equal negative 1/2 from 0 to 2 pi? So once around the circle, where does it happen? 2 places, yes. Okay, is negative pi over 6 between 0 and 2 pi? Okay, and where else? Yes. Do you see the difference between that kind of question and the evaluate? Okay. No, it got real intense. It's the whole circle. Yes. I like the visual of the calendar better. Like, yeah, than just like the list of dates. I'm like, I don't know. Yeah, great. Okay, guys. We have a good chunk of time left. As I said, today would be a pretty easy day. Friday's a pretty easy day. That's it for notes. Okay. We're not doing 7-2 today. No. Guys, I wouldn't have it in for grades, probably. Like, I wouldn't have the replacements again. So. All right. So the expectation is you will get your math space done now. Some of you have not done well on homework. So open, start, do it now. I will check. I will call you out.
It changed to a B.
What?
Yeah. Right after I checked with the test, it's an A. And then I looked again today for B.
For your homework?
Yeah.
So let me look, because Nana asked me too, and I'm like, it's still an A for her. So let me look.
Maybe cis B.
It might have just been cis B.
I know my math space and the read. Even if I get a first out.
I like that. And look how well you did on your test.
And then I did help Jackson.
That's good.
Yeah, that's what I was like.
Did you do the delta math?
No.
That's why it's a B.
And
It's showing as an A for me. I see yours as an A. Yeah, I just looked. Show me if it's a B. It's showing as an A for me. It's not okay if they don't match. Yeah. Good luck.
So it doesn't matter. I know how it doesn't matter. It's not grading. Yeah, but it shows. A delta math and in math space. Maybe if I missed it.
That's where my mark is. So I go through the second attempt. So let's see.
It's rolling with you. I don't know. No, you should have an A.
I have a double check math space, but I don't ever have to assist.
Well, I have this open right now too. I have you with an A for the homework. Yeah. Look again. I haven't changed anything like today for you guys.
I was gonna like an error message. Obviously.
Well, that's not good. Okay.
Yesterday it was Can
I mistyped yesterday, but I fixed it this morning, so I bet that's it.
I see what I got?
A B. Because you never did 6-2.
Oh. Okay.
I missed one, so you got a B.
Okay.
Hey, how do you see it now? Is it right? Okay. I mistyped yesterday. I know that. I fixed it this morning. So that's fine. Nope. What I did was typed your test grade in, and then I actually went and typed your homework grade in. So. Yes. But they're quick, most of them. The estimated time is like 16 minutes. So. What's up? Yeah, if you don't get above an 80 the first time, then it's like you didn't do it. Yeah. Hey, Sri. No, just the where is it? The calendar. The calendar one. That's all I handed out today. And then we just did notes for 7-1. Super short and simple. I'll post the video like right now, so you can get caught up.
It's gotta be cosine.
Yeah. Oh my God, it's gonna be only negative 5.